Hello again. So today the new section is we want to find the length of a line segment and the midpoint of a line segment. First, what is a line segment? It's basically a part of a line where there are two endpoints. So you got a endpoint right here, right there with that coordinates, and there's an endpoint right there. And notice that there is no line. This line doesn't continue forever. That's called a line segment. It's got two endpoints, and that's basically it. Now, the length of a line segment, we just want to know what is the length from this point A to point B. Let's suppose we call it A and B. What is the distance between the two? That's it. That's the length of a line segment. And so as the next one, if you want to look at the C and D, we want to know what the length is. And in this case, these two examples that I've given you, they're very straightforward. You can count, really, that's simple. You can go, so this is -5. So the horizontal, there's no vertical, so there's from here to here, you just count how many that is. So from -5, you're going all the way to 6. So this distance right here, there's 11 units. So basically, simple as that. Now, there is a form that you can use to get that, but that's basically it. You can count, but really how you got the 11 is the difference between a 6 and a -5. Or you can say 6 minus -5. That's the difference, which is right here. That's called the difference, that negative. That is actually 6 plus 5. Therefore, there's 11 units in between. But you can count it straightforward. Now, same thing with the next one. Is the vertical. We want to know the vertical distance. That's no problem. You can count up. So it is basically from 0 down to -7. So basically this is 7 units. Simple as that. Or you can say you can say 0 minus -7. That will give you +7. The difference between the two value again. So, but you can count. But the problem is, what happens if that is a slanted? Okay, so it's not on a horizontal or a vertical kind of a position, but it's on a diagonal position. Now that is a new thing that we need to work on. Okay, so now we have this example B right here. And this example has got a slanted line, and we want to know the length of this line. Now we can't just count anymore because it will not be true. We don't know if it's 1 over each of these kind of diagonal lines that go through each of these smaller squares. They are 1 unit. They are not actually. So what are we going to do? You have to use a relation that you actually got to know a couple of years ago. It's called the Pythagorean theorem. Okay, and the Pythagorean theorem is basically based on the right angle triangle. If I can draw a right angle triangle, and this right angle triangle is got the A and B as the sides, the legs, and then the longest side that is opposite of the 90-degree angle, because the two sides, they have to be perpendicular to each other. That means hitting at each other at 90 degrees. The side opposite of that is the longest side, which is called the hypotenuse. And you already know what that is. And what it was is that c squared, this was the relation, c squared is equal to a squared plus b squared. And that's what we're going to use here. Now what you have to do, you have to create this right angle triangle using this slanted, and this slanted line is actually the hypotenuse of this invisible triangle that you're going to draw. So here's what we're going to do. We're going to go up, straight up from the first point that we have, which is that coordinate right there. We're going to go straight up, and then we're going to go straight across. So now we have created this right angle triangle. Now we can say, okay, how far up did we go? So we went from 3 all the way to 10. So this should be, you can count, that's 7 units. Also, we went from -7, which is right here, to 0, so that would be 7 units again. All right, so it turns out that is isosceles right angle triangle. Great. Now we have to use Pythagorean to come up with the length of this, and Pythagorean says a squared plus b squared equal to c squared. So c squared we don't know, that's the length of the, let's call this AB, the line segment AB. So I'm going to call that AB instead. So AB, the line segment, and that bar little on top, that's the line segment, squared, that's a line segment notation, equal to 7 squared plus another 7 squared. So 49 plus 49, but it is a square. We don't need AB squared, we need AB. So what should we do to undo the exponent 2? We have to take the square root. And that's what we're going to do. We're going to take the square root of 98. Now, remember, if you can, your simplification of radicals, you can simplify 98, that's the entire radical. You can simplify it as a mixed radical, and that is basically 2 times 49, and basically that becomes 7 root 2. That is the length of the line segment AB, 7 root 2 unit, whatever the unit is. And that's how you get the length of a line segment using the coordinates. So the coordinates, if you have two coordinates, x1, y1, and x2, y2, any 2 points at the end of the line segments, you can use this relation. Here it is, and this is basically a fancy way of writing this Pythagorean. All right, you don't have to memorize that if you don't want to. You just make sure you draw the diagram properly. You can actually use this diagram right here that I have done. You can use that type of a kind of a process to come up with the length of a line segment. For the midpoint, is basically very simple. It's basically the middle of the line segment, and it's the average of the x values and average of the y values for the x and y coordinates of the midpoint. So suppose we have this AB line segments, x1 and y1 is basically random coordinates for A, and x2, y2 random coordinates for B. The midpoint for this, which is somewhere around here, and I'm just guessing visually, is basically when you have this set up, and whatever the values for x1 and x1 and x2 is, we plug it in, and then we just get the answer for each of the coordinates. So let's go ahead with an example. So here is the example right here. That's the example, and very simply, we've got two coordinates, -8 and -1 for a point A, and B is 2 and 9. For x midpoint value, we use the x right here and x right there. That's what we're doing. We're adding them and dividing by 2. We simplify, you get -3. And then you do the same thing with the y value. This is the y value here. That's the y value there. Here it is. We add them, divided by 2. That's how you get the average. And then once you get 4. And here is the total, the final answer for the midpoint, which is right there, -3, 4. And that's the -3, 4 for the midpoint. Let's call it M. Okay, that's simple as that.